Hey guys, hopefully you were here for our super fun crime time lesson, but if you missed it or if you just need some extra assistance, then this video is for you. We're going over correlation coefficient, line of best fit, and making predictions. Now these are things you are familiar with from 8th grade, all with the exception of the correlation coefficient. Line of best fit, right? Finding a line that best fits the data, where that means we're talking about scatter plots, and then making predictions on what we think will happen, right? We use the line of best fit to do that. So a correlation coefficient is just the strength of our line of best fit. Basically, it's telling us how linear it is, or how close to linear it is, right? It's not going to be an exact line, probably, because it's just a scatter plot. It's not a specific set of information that's going to create a line, or if it is, then it's a linear function. But if it's like this graph that you see on your notes page, it's not quite a line, but it's fairly close to a line, and so our correlation coefficient would be fairly strong. And if you look, I'm going to highlight this in yellow. Right here, we actually have a table that will tell you whether or not you have a strong, moderate, or weak, or none correlation. And you can have a correlation coefficient that is either positive or negative, depending on the direction of the graph. So we use the letter R to denote our correlation coefficient. If you've been using linear regression, where you put in a table of information and then you find the equation, that's actually used to find the line of best fit for scatterplot data, but it also works for linear functions. And you might have noticed that there was an R value that it gave you. That R value is the correlation coefficient. So the closer it is to 1, or to -1, the stronger it is. Right? It says it's strong if it's anywhere from 0.8 to 1, or from -0.8 to -1. And then the closer to 0 it is, the less correlation there is. You see from 0.3 to 0, or from -0.3 to 0, that is no correlation. And you can see also weak or moderate. And that's what those graphs there right below it show us. All right, so we can kind of label these. Well, they're pretty strong. And that first one, right, looks almost linear. Moderate, I'm just going to put mod. This next one is fairly weak, right? It's pretty spread out. And then no correlation right there on that last one. All right, so we are actually going to look at a problem, and we're going to be able to find the correlation coefficient of it and determine if it's strong or weak, determine the actual line of best fit, right? That's another thing we can say is regression, which you already know how to do in your calculator, so that's awesome. And then make predictions based on that data. We'll be able to answer a question using our line of best fit to help us answer. So a zookeeper recorded the feeding schedule for a baby rhinoceros for 20 weeks. The table and scatter plots show the percentage of the baby rhinoceros's body mass that was used to determine the amount of food given at each feeding. That says teach feeding. Definitely should be each. What's this cool trick? Okay. So at each feeding, as a linear function of its age in weeks. So it gives us a table of data, and then it gives us the graph as well. Now we could graph this information if we wanted to using our calculator. And as you see on here, we actually give you the calculator instructions. So put your data into lists and spreadsheets, right? That's that green middle box on your home screen, if you want to make a note of that. And then after you put your information in, make sure you label X and Y. I would say that. It's important to do that. It won't work if you don't. Then you do menu 4, 1, 3. It's actually going to take a little bit more than that. And I kind of like to look at my data a little bit a different way, and I will show you the video instructions for that now. Okay, so if I have this data and I want to put it in the calculator, I'm going to go to lists and spreadsheets, which is that green middle one, like I said, and then I'm going to go ahead and enter my data right here. I've already done it. I made sure to label X and Y, and I've inputted all of my X values and then all of my Y values, like you can see. You can go to menu, 4, 1, and then 3 linear regressions. Type in X for here, type in Y for here, press OK. Yes, go for it. And it gives you your linear regression, it gives you your slope, your y-intercept, and it gives you your R value as well. So that kind of is how you would put the information in. If you wanted to graph it, I would go back home and you could go over to this purple one, add your variables as X and Y, just labeling your axes. It creates that same graph that you see, but with a different scale. And then you could find the equation by doing analyze regression, fancy name for line of best fit, and then show linear. And this would give you the equation. It wouldn't give you your R value to see the strength, but you can also see the strength via eyeball. And then you'd be able to tab back and forth here to see that information. Okay, and remember, this one is just menu, 4, 1, and then 3. To get that right, X, Y. Don't need anything else. Okay, and that would give you your information. So when I found my answers, I found that I had a M value that was negative 0.5448 continued, and then a B value of 19.80265 continued, right? And they weren't pretty numbers, right? It's giving us our line of best fit, which may or may not always be pretty. It gave me an R squared value, which we don't need to worry about, and then an R value below that, and that R value is what we care about. It's the correlation coefficient, and that value, if you found it with me on your calculator, is negative 0.984. It's longer than that, but we're just going to go with there. That's good enough for our purposes. Okay, it should be a negative value because, as you can see, our data plotted on the graph is negative, right? It's going down as we move across the graph. And because it is negative 0.984, it is classified as a strong correlation. Right, it's super close to -1. So it's negative, right? It's an actual negative value. And then it is, in fact, strong. Now that we have this data, we can actually use it to answer some questions. So we can write the linear regression. So y equals negative 0.545 is what we're going to use. X plus, and we'll just do 19.8 since it's a 0 after that. Okay, so that's about what our line is. And using that, we can make predictions. So it says, what is the best prediction of the percentage of the baby rhinoceros's body mass that should be used to determine the amount of food given at each feeding when it's 25 weeks old? So now we want to know when it's 25 weeks old. The table only goes to 20 weeks. So we want to go 5 weeks from there. Well, since we have an equation, we know what X and Y are, right? X would be the age in weeks, and Y would be the percentage of body mass. We have an equation. We can plug in 25 for X. 25 is an X value into our equation and find the answer. So in my calculator, I'm going to go to my calculating tab, right, and I'm going to type in what would happen if I did negative 0.545 times 25 weeks and then add 19.8. When I do that, it says that it would be about 6.175. Oops. Right, and that would be the percentage of body mass. that we should use for feeding. And it is less than the previous one we saw, right? So we know that we answered it semi-correctly at least. And then remember, it's just a percentage. We could also use a graph. If we were to graph this line, we could find what the y value when x is 25, or use our trace feature on our calculator to find what the x value is. And it's just a prediction for what we think might happen based on the trends that we saw for the rhinoceros. Let me know if you have any questions.